Hello everybody, we're now on lesson number 2, which is talking about special quadrilaterals. I can't pronounce the word quadrilaterals very well, so you're going to hear me say the word quads throughout the rest of this video. Okay, so that's what I'm talking about when we get there. So let's talk about the 3 special types of quads that we need to discuss. The first one is a rectangle. A rectangle is just a quad with 4 right angles. So I'm going to quickly draw you an example of one of those. I know you've seen them some point in your life, but in case you forgot, here is a rectangle. All right, we have 1, 2, 3, 4 90-degree angles. Then we got the rhombus. A rhombus is a quad with 4 congruent sides. A lot of you guys think of this as a diamond. It's not a diamond. Diamonds are 3-dimensional. Okay, this is a rhombus, and we have 4 congruent sides. Then we have the square. A square is a quad with 4 right angles and 4 congruent sides. So in case you forgot what these look like, we have 4 congruent sides and we have 4 90-degree angles. Now, if you remember from the lesson previous to this, we were talking about parallelograms, and I had called parallelogram, I called it the granddaddy parallelogram. Well, there's a reason for that. Because we can prove that a rectangle is a type of parallelogram because opposite angles, both pairs, are congruent. So a rectangle is a type of parallelogram. We can look at rhombus and we can prove the same thing, but using opposite sides congruent, right? Because we have both pairs of opposite sides congruent, that makes a rhombus a type of parallelogram. So I think of parallelogram as the granddaddy, and then we get rectangles and rhombus, which would be the mama and dada, right? Mommy and daddy of baby square, right? Because a square is basically a rectangle and a rhombus combined, right? We've got the 4 90s and we've got the 4 congruent sides, which is traits from rectangle and rhombus. So a square is both a rhombus and rectangle, and because rhombus and rectangles are parallelograms, that means a square is also a parallelogram. So, thinking family tree wise, right? You got parallelogram, and then rectangle rhombus would be the mom and dad, square would be the baby. Okay? That's how I think of it. Or you could look at it in a Venn diagram, which, by the way, this is an ugly looking Venn diagram, and I'm pretty sure my college professor would freak out if she saw this drawn so poorly. So just pretend it looks nice. That's what I usually do. Right? So let's talk about it. We've got out here will be polygons, right? Just shapes, different numbers of sides. But then we have a special section that we're going to refer to with the quadrilaterals, right? 4-sided shapes. There's all sorts of 4-sided shapes, right? You got these ugly looking things, right? You got trapezoids, you got kites. But we have special ones that we talked about last time, which are parallelograms. Parallelograms. Okay? And there's really only one here specifically that we talk about, right? Opposite sides are parallel, and the rest of the 4 theorems we talked about, 3 theorems we talked about yesterday. Okay, but now in our Venn diagram we can start talking about rhombus and rectangle, right? Because they're still quads, so is a parallelogram, but they're special parallelograms, and they're unique to each other, right? Rectangle doesn't have equal sides. Rhombus doesn't have the 90s. And then finally, where these two do share some similarities is where square comes in. Okay, so I have now given you not just a verbal idea of a family tree and then inheriting genes, but we also have a visual. How this visual works is that if something is true out here for quads, it would have to be true for anything inside. So if it's true for quads, it's true for parallelograms, rectangles, and squares. If we have something true for parallelograms, it has to be true for rectangles, rhombus, and squares. But if I talk about something in rhombus being true, it doesn't necessarily leak out to parallelograms. It doesn't necessarily leak out to rectangles. The only thing that shares would be square, because squares are located inside of the rhombus section. Okay, so if you want to use a Venn diagram as a reference, draw this real quick and use it as a reference. If you want to think of it as a family tree type of thing, I like that personally a little bit better. It's a little bit easier for me to follow, but however you want to work with it, work with it. But here's what's going to happen. We have some theorems. So not only do we have definitions, but we have theorems that work with these shapes as well. So when we talk about this first theorem with rectangles, it tells us that the diagonals of a rectangle are congruent. We talked yesterday that the parallelograms diagonals bisect each other. So not only the diagonals bisect each other for rectangle, but they're also congruent or equal in length. Is that true for a rhombus? No. But is it true for a square? Yeah, because a square is a type of rectangle. So we know then that squares also have congruent diagonals. Then we have rhombus, theorem number 1, which talks about diagonals again. It says the diagonals of rhombus are perpendicular. So we look at the diagonals, they're going to cross at a 90. That is not true for all parallelograms. It's not true for rectangle. However, it's going to be true for square. So a square gets both of these so far, right? Congruent diagonals and perpendicular diagonals, because it's kind of like the baby inheriting those traits from mom and dad. Okay, and then finally, rhombus theorem number 2. This one's not as easy to remember, but it says diagonals bisect the vertex angles. Okay, so that's true for rhombus here. It's going to be true for square as well. And I'm going to quickly just draw us a little bit of an example of what this looks like. Okay, here's our rhombus. Each of these are considered a vertex angle, and because it's a parallelogram, we know that this and this angle are congruent, and these two opposites are congruent as well. Okay, so we know that they're congruent, and they're vertex angles. What's happening is when we draw in our diagonals, not only do we get them to be 90 degrees at the intersection, but the angles themselves, right, this angle, which is congruent, they're being cut in half. They're being bisected. So I'm going to get equal angles on the top and bottom. Same idea happens here, right? These two angles are congruent, but they're being cut in half. So I have two angles over here that are congruent to two angles over here. Okay, that's what happens when you bisect the vertex angles. So, we've got a couple of problems, only 2 this time. Nice short lesson. But what you're going to want to keep in mind is which properties we need to use, which theorems are associated. Okay? So, here you go. This problem says if QS equals 20, we want to find the length of TM. What you need to do first is decide what type of quad we're working with. This looks to be like a rectangle, not a square because I don't have equal length sides, but a rectangle because I have the 490s. So I'm going to do a little bit of labeling. I know QS is worth 20. Because this is a rectangle, I know then that TR is going to also be 20. They're congruent in length. That's all it has to do with rectangle. How are we going to get TM though? Well, if we remember that this is a type of parallelogram, we remember then that the diagonals are getting bisected or cut in half. So if TR is worth 20 and we cut it in half at point M, that means that TM is going to be worth 10. There is one more problem for us to look at. If you want to try this one out on your own, you can pause the video and resume when you're ready to check your solutions. I know it doesn't say you try, so that's up to you. Alright, let's see how this is done out. They tell us that we need to solve for x and y, and they tell us the measure of angle ABC is 110 degrees. I goofed a little bit, guys, huh? I forgot to put x and y in the problem. Here's y, 11y, and here's x, 9x. So I'm sorry about that. Why don't you try it now that you have the variables there, and resume when you're ready to check your solutions. Alright, now we can actually check it out, because now we have the variables there. So here's what's happening. We have a rhombus, right? We have 4 congruent sides. It's a rhombus. So we need to think about a couple of properties or theorems that have to do with rhombus, right? One of them is that the diagonals are perpendicular. Our diagonals are already drawn in. So that means that this angle here is worth 90. But not just there, here as well, where our x lives. So that means 9x is the same as a 90-degree angle. All we have to do is divide, and we get x equals 10. The other theorem that we want to think of for rhombus is that the vertex angle, which we see an angle including y up here, is being bisected by that diagonal. Now they told us that this full thing, ABC, is 110 degrees. But because it's being bisected and we're only working with 1/2 of it, we know that we're going to be getting 55 here, right? This little piece here is worth 55. So we take 11y, set it equal to 55, and divide by 11. How did you do with that one? Probably way better when you had the variables there, huh? Well, that's really it for your special quads lesson. Any questions you want to bring into class, I'd be more than happy to answer for you, or you can leave them on the comment section. Either way. All right, I will talk to you all soon. Bye.